Right now, as you listen to this, something extraordinarily rare and never recorded before is hurtling through our solar system at about 140,000 miles per hour. It carries chemistry from another star, metals combined in ways not yet explained by current models, and a trajectory so precisely aimed at our planetary neighbourhood that the odds are estimated to be extremely small, perhaps a fraction of a percent. Its name is 3I/ATLAS, and it might be the most important visitor we've never invited. Take a breath and consider this unsettling possibility. What if the universe doesn't just randomly scatter objects between stars? What if there's something more deliberate about how these ancient wanderers find their way to us? I'm here to walk with you through one of the most profound mysteries unfolding right above our heads. A story that challenges everything we thought we knew about the space between stars, about the nature of cosmic coincidence, and perhaps about our own place in a galaxy that might be far more interconnected than we ever dared imagine. Welcome to an exploration that will shift how you see the night sky forever. Chapter 1: The Stranger That Shouldn't Exist. On July 1st, 2025, a robotic eye in the Chilean desert captured something that would rewrite astronomical textbooks. The Atlas Survey Telescope, designed to spot dangerous asteroids heading toward Earth, instead photographed our solar system's third confirmed visitor from another star system. But 3I/ATLAS wasn't just another interstellar wanderer. It was an anomaly wrapped in an impossibility. Picture this moment of discovery. Astronomers had been tracking objects for decades, cataloguing the predictable dance of planets, asteroids, and comets that call our sun home. Then suddenly, there it was, a fuzzy dot moving against a stellar background with velocities that screamed of alien origins. Not alien in the science fiction sense, but genuinely foreign to everything our sun had ever created. The mathematics were undeniable. 3I/ATLAS follows what scientists call a hyperbolic trajectory, carrying more than enough speed to escape our sun's gravitational embrace entirely. This object had come from somewhere else, travelled for potentially billions of years through the vast emptiness between stars, and somehow found its way to us. But here's where the story becomes deeply unsettling. As you settle into this narrative, notice how the details begin to accumulate, like evidence in a case we never expected to investigate. The first clue came from the object's brightness. When astronomers first spotted 3I/ATLAS, it appeared far too luminous for its distance from the sun. If all that light was simply reflected sunlight, the object would need to be roughly 20 kilometers across, a massive mountain of ice and rock tumbling through interstellar space. The statistical probability of discovering such a giant first, approximately 1 in 10,000. Think about that for a moment. Imagine reaching into a jar containing 10,000 marbles, where only one is painted gold, and pulling out the golden marble on your very first try. That's the level of cosmic coincidence we're discussing. The second clue emerged from its chemical signature. When the James Webb Space Telescope turned its infrared eye toward 3I/ATLAS, it revealed something unprecedented in the annals of comet science. The object's atmosphere, what astronomers call its coma, consists almost entirely of carbon dioxide. 95% carbon dioxide, only 5% water, with virtually no carbon monoxide. This composition is so unusual it borders on impossible for natural solar system objects. Most comets are dirty snowballs dominated by water ice, with carbon dioxide playing a supporting role. 3I/ATLAS appears to have this relationship completely reversed, suggesting formation conditions unlike anything in our cosmic neighbourhood. But the third clue is perhaps the most disturbing of all. Spectroscopic analysis revealed that 3I/ATLAS is emitting streams of metallic nickel vapor, pure nickel, with absolutely no trace of iron. In the cosmic chemistry textbook, nickel and iron are inseparable twins, forged together in stellar cores and found together in virtually every space rock, asteroid, and comet ever studied. The separation of nickel from iron doesn't happen naturally in space. It requires industrial processes, advanced metallurgy, or conditions so exotic that we have no natural examples to reference. On Earth, we routinely separate these metals for manufacturing specialized alloys and electronics. But finding this signature in an object from another star system raises questions that make astronomers profoundly uncomfortable. As you absorb these details, you might find yourself wondering, as I did, whether we're witnessing something that challenges our most fundamental assumptions about how the universe works. Chapter 2: The Trajectory of Impossible Precision. The path 3I/ATLAS follows through our solar system, tells a story that grows more mysterious with each calculation. This isn't a random trajectory that happened to intersect our neighborhood. It's a precisely choreographed dance that brings the object remarkably close to multiple planets, with timing that seems almost too convenient to be coincidental. Consider the geometric elegance of its approach. 3I/ATLAS will sweep past Mars on October 3, 2025, at a distance of just 30 million kilometers, close enough for spacecraft orbiting the red planet to capture detailed observations. Then it continues sunward, reaching its closest approach to our star on October 30th, positioned perfectly for maximum solar heating while remaining safely distant from Earth. The orbital mechanics reveal something even more intriguing. The object's trajectory lies almost precisely aligned with the ecliptic plane, the flat disk containing most planetary orbits. Random interstellar objects approaching from arbitrary directions in three-dimensional space would be expected to arrive at steep angles to this plane. Instead, 3I/ATLAS approaches as if it understands the architecture of our solar system. Harvard astrophysicist Avi Loeb has calculated the probability of such precise alignment. His analysis suggests the odds are approximately 1 in 500, possible but suspiciously unlikely for a random cosmic accident. Take a moment to imagine what this means. Picture our solar system as a flat dinner plate floating in three-dimensional space. Most objects arriving from random directions would approach from above or below, cutting through the plate at steep angles. But 3I/ATLAS glides in along the plane of the plate, as if following a predetermined flight path designed to provide optimal access to our planetary neighborhood. The timing adds another layer of mystery. The object's closest approach to the Sun occurs during superior conjunction, when it appears too close to our star for Earth-based telescopes to observe. This creates a natural observational blackout during the period when solar heating should trigger the most dramatic changes in the comet's behavior. From a reconnaissance perspective, this timing would be ideal for conducting clandestine operations. The object could undergo significant activity changes, deploy hidden mechanisms, or perform complex maneuvers while effectively invisible to human observation. Whether such considerations are relevant depends on questions that push the boundaries of scientific speculation. Chapter 3: Messages from an Ancient Galaxy. The age of 3I/ATLAS tells a story that extends back to the dawn of galactic civilization. Recent analysis suggests this object formed approximately 4.6 billion years ago in the Milky Way's thick disk, a region populated by ancient stars with chemical compositions dramatically different from our Sun's neighborhood. To understand the significance of this age, consider that 3I/ATLAS is potentially older than Earth itself. When this object condensed from the debris disk surrounding its parent star, our solar system didn't exist. The Sun was still a diffuse cloud of gas and dust, perhaps not even gravitationally bound. Life on Earth was still 4 billion years in the future. This means we're observing chemistry from an epoch when our galaxy looked fundamentally different. Star formation rates were higher, heavy element abundances were lower, and the conditions for planetary formation operated according to parameters we can barely reconstruct through theoretical models. The exotic carbon dioxide-rich composition suddenly makes sense in this context. Ancient stellar systems formed under different temperature and pressure regimes might naturally produce comets with chemical signatures that appear impossible by modern standards. We're not just studying an unusual object, we're examining a time capsule from galactic prehistory. As you contemplate this temporal scale, notice how it transforms our understanding of what 3I/ATLAS represents. This isn't simply a visitor from another star system. It's a messenger from another era of cosmic evolution, carrying information about planetary formation processes that operated when the universe was young. The metallic emissions take on new significance when viewed through this ancient lens. Stellar nucleosynthesis, the process by which stars forge heavy elements in their cores, might have operated differently in the early galaxy. Perhaps conditions existed that could naturally separate nickel from iron, creating compositions that seem artificial by contemporary standards. Yet questions remain that push beyond comfortable scientific explanations. How does an object survive billions of years of interstellar travel while maintaining the structural integrity necessary for complex chemical emissions? What preservation mechanisms could protect delicate molecular structures through cosmic ray bombardment, gravitational perturbations, and the extreme temperature variations of interstellar space? The journey 3I/ATLAS has completed defies easy comprehension. Travelling at interstellar velocities for billions of years, it has likely encountered the gravitational fields of dozens of stars, passed through multiple stellar wind environments, and endured radiation doses that would sterilize most known materials. Yet it arrives in our solar system apparently intact, immediately beginning to outgas complex chemistry, as solar heating activates processes that may have been dormant for longer than complex life has existed on Earth. Chapter 4. The Awakening. Something remarkable is happening to 3I/ATLAS as it approaches our Sun. The object is brightening far beyond theoretical predictions, developing an atmospheric coma larger than Earth, and displaying activity patterns that challenge fundamental assumptions about comet behavior. When astronomers first calculated how bright 3I/ATLAS should become during its solar approach, they used models based on decades of studying solar system comets. These predictions assumed standard volatile compositions, typical outgassing rates, and conventional responses to solar heating. Instead, 3I/ATLAS has been consistently exceeding brightness expectations, sometimes by several magnitude levels. In astronomical terms, this represents a 6-fold to 10-fold increase in luminosity over predicted values. A deviation so significant, it suggests processes operating beyond current theoretical frameworks. The coma development tells an equally extraordinary story. High-resolution images from the Gran Telescopio Canarias reveal an atmospheric envelope spanning 26,400 by 24,700 kilometers, roughly twice Earth's diameter. This vast cloud of gas and dust is expanding as the object approaches perihelion, creating a bubble of interstellar chemistry larger than some planets. But perhaps most intriguingly, the timing of these changes suggests a threshold effect. The dramatic brightening began when 3I/ATLAS crossed approximately 2 astronomical units from the Sun, a distance that seems to have triggered fundamental changes in the object's behavior. As you consider these observations, you might find yourself wondering what it means for something to wake up after billions of years of dormancy. The chemistry we're observing may be experiencing solar radiation for the first time since the object's formation around another star. Exotic ices, stable only in interstellar conditions, are sublimating into space, releasing molecular signatures that have been locked away since the galaxy's youth. This awakening process raises profound questions about information storage and retrieval on cosmic scales. If 3I/ATLAS has indeed preserved chemical signatures from ancient stellar environments, what other information might be encoded in its structure? Could the complex organic molecules detected in its coma represent a form of cosmic data storage, carrying information about conditions in stellar systems that existed billions of years ago? The answers to these questions will emerge as 3I/ATLAS continues its hidden passage behind the Sun, undergoing transformations we can only imagine. When it re-emerges in December, we may discover whether we've been witnessing the natural awakening of ancient chemistry, or something far more remarkable, a message from the deep past, delivered by a messenger we never invited but somehow always expected. Next time, we'll explore what happens when our most sophisticated instruments turn their attention to decoding the signals from 3I/ATLAS, and why some scientists believe we're witnessing evidence of technologies that operate on principles we're only beginning to understand. Until then, keep looking up, and remember, the universe has been sending us messages long before we learned how to listen. If this exploration of cosmic mysteries has captured your imagination, you might find our previous investigation equally fascinating. We asked the universe the big questions and got terrifying answers. Sometimes, the most profound discoveries come from questions we're almost afraid to ask. Chapter 5. The Observatory Network Awakens. As autumn deepened in 2025, something unprecedented began happening across our planet's network of telescopes. From the volcanic peaks of Mauna Kea to the radio-quiet valleys of Chile's Atacama Desert, humanity's most sophisticated instruments were turning toward a single target with an urgency typically reserved for planetary emergencies. Yet this wasn't about immediate danger. This was about opportunity, perhaps the most significant observational opportunity in the history of interstellar astronomy. Every major space agency, research institution, and university observatory was coordinating what would become the largest simultaneous observation campaign ever mounted for a single celestial object. Consider the logistical complexity of this undertaking. NASA assets alone included Hubble, Webb, TESS, SWIFT, SphereX, and the Mars-based fleet of rovers and orbiters. The European Space Agency contributed Mars Express, the ExoMars Trace Gas Orbiter, and even repositioned JUICE, originally destined for Jupiter's moons, to capture additional observations. Ground-based facilities across 6 continents synchronized their schedules, sharing telescope time in ways that transcended normal institutional boundaries. As you contemplate this global mobilization, notice how it reflects something profound about our species. When confronted with mystery that challenges our understanding, we instinctively coordinate, collaborate, and focus our collective technological capabilities with remarkable precision. The Mars-based observations presented unique opportunities and challenges. On October 3rd, as 3I/ATLAS swept past the Red Planet at 30 million kilometers, spacecraft designed to study Martian geology suddenly found themselves repurposed as interstellar object investigators. The Mars Reconnaissance Orbiter's high-resolution cameras, normally focused downward at ancient riverbeds and crater formations, pivoted to track a visitor whose origins predated Mars's geological history. The viewing geometry from Mars offered perspectives impossible from Earth. Different solar phase angles revealed hidden details of our coma structure and tail dynamics. The European Space Agency's Trace Gas Orbiter, equipped with spectrometers designed to detect methane in the Martian atmosphere, instead analysed the exotic chemistry streaming from an object that formed around another star. Yet even as this unprecedented coordination unfolded, a cosmic conspiracy was simultaneously working against human observation. 3I/ATLAS was approaching superior conjunction, the period when its position relative to Earth would place it too close to the Sun's overwhelming glare for most telescopes to function effectively. Chapter 6. The Hidden Transformation. The cruel irony of celestial mechanics became apparent as October progressed. Just as 3I/ATLAS was approaching its most scientifically valuable phase, peak solar heating that would drive maximum outgassing and potentially reveal subsurface chemistry preserved since the object's formation. It was simultaneously disappearing from Earth's observational reach. Picture the frustration of astronomers worldwide as their target gradually merged with the solar glare. Professional observatories with sophisticated coronagraphs and adaptive optics systems could extend observations slightly longer than amateur telescopes, but even they faced increasingly hopeless conditions as the object's solar elongation decreased below critical thresholds. By mid-October, 3I/ATLAS had effectively vanished from Earth-based observation, hidden behind the same star whose radiation was triggering the most dramatic transformations in the comet's 4-billion-year existence. The timing created what researchers diplomatically termed observational challenges, though privately many described it as a cosmic practical joke. During this hidden passage, theoretical models predicted that 3I/ATLAS should experience its most intense activity: maximum volatile sublimation, possible structural changes, and the release of deeply buried chemistry that had remained stable throughout the object's interstellar journey. Yet all of this was occurring essentially invisible to human observation, preserved only in whatever indirect evidence might survive for later analysis. The Parker Solar Probe, humanity's fastest spacecraft and the closest artificial object to the Sun, operated in the inner solar system where it might theoretically encounter material from 3I/ATLAS's expanding coma. However, the probe's highly elliptical orbit and focus on solar phenomena limited its utility for systematic comet observations. It was designed to study our star's corona, not to intercept ancient chemistry from other stellar systems. As you consider this observational blackout, reflect on how it mirrors challenges we face in understanding any complex system. The most critical moments of transformation often occur precisely when our normal methods of observation fail us. Sometimes the most important changes happen in darkness, requiring patience and trust. That emergence will eventually reveal what transformation has accomplished. Chapter 7. Spectroscopic Revelations. Before 3I/ATLAS disappeared into solar conjunction, the brief window of detailed spectroscopic observation had yielded data that would occupy researchers for years. The James Webb Space Telescope's August observations represented perhaps the most comprehensive chemical analysis ever performed on an interstellar object, revealing molecular signatures that challenged fundamental assumptions about comet formation throughout the galaxy. The carbon dioxide dominance wasn't just unusual, it was revolutionary. In 4 billion years of solar system formation, no natural process had been identified that could produce such extreme CO2 concentrations while suppressing water ice formation to such minimal levels. This suggested that 3I/ATLAS formed in a stellar environment with temperature and pressure conditions radically different from our Sun's protoplanetary disk. But the metallic emissions opened even more profound questions. The continuous stream of nickel vapor, 4.6 grams per second by late August, represented chemistry that had no known natural parallel. In terrestrial geology, nickel and iron are found together in ratios reflecting their cosmic abundance patterns. Their separation requires high-temperature industrial processes or conditions so exotic that no natural examples exist in our experience. The implications extended beyond simple chemical curiosity. If 3I/ATLAS had indeed formed around an ancient star in the galaxy's thick disk, its chemistry preserved information about stellar nucleosynthesis processes operating under conditions we could barely reconstruct through theoretical models. We might be observing evidence of planetary formation mechanisms that operated when the universe was young, when stellar masses, metallicities, and disk dynamics differed dramatically from contemporary star-forming regions. Take a moment to appreciate the temporal scale of this discovery. The molecules we were detecting had potentially been locked in solid form for longer than complex life had existed on Earth. Every spectroscopic line represented a direct sample from galactic prehistory, carried across vast distances and timescales to arrive precisely when human technology had advanced enough to decode its significance. The organic chemistry detected in the coma added another layer of mystery. Complex carbon-bearing molecules, including cyanide compounds and various hydrocarbon species, were sublimating from the nucleus as solar heating penetrated surface layers that had remained frozen since the galaxy's youth. These weren't just random chemical combinations, they represented structured molecular assemblages that had survived the rigors of interstellar travel while maintaining their integrity across billions of years. Chapter 8: The Mathematics of Coincidence. As observational data accumulated, a disturbing pattern emerged in the statistical analysis of 3I/ATLAS's characteristics. Each unusual feature, the precise trajectory, the exotic chemistry, the improbable timing, might be explained individually through natural processes operating at the extreme end of probability distributions. But their simultaneous occurrence in a single object pushed the boundaries of what coincidence could reasonably explain. Harvard's Avi Loeb, whose controversial interpretations of interstellar objects had sparked debates throughout the astronomical community, published calculations that quantified these statistical anomalies. The probability of discovering an object of 3I/ATLAS's apparent size first, rather than the thousands of smaller objects that should statistically dominate the interstellar population, approached 1 in 10,000. The trajectory alignment with the ecliptic plane added another factor of approximately 1 in 500. The chemical composition, while theoretically possible, represented conditions so rare that no solar system analogue existed for comparison. When these probabilities were combined, the likelihood of 3I/ATLAS representing a random natural occurrence became vanishingly small. Yet Loeb himself acknowledged the speculative nature of such calculations. Extraordinary claims require extraordinary evidence, and the boundary between rigorous statistical analysis and scientific speculation remained contentious within the research community. The absence of obvious artificial signatures, radio transmissions, geometric structures, or directed motion argued strongly for natural explanations, however improbable they might appear. As you contemplate these statistical considerations, notice how they reflect broader questions about the nature of evidence and the limits of scientific inference. How do we distinguish between genuinely anomalous phenomena and the inevitable outliers that probability theory predicts must occasionally occur? When does healthy scientific skepticism become closed-minded rejection of possibilities that challenge our assumptions? The debate surrounding 3I/ATLAS revealed deep philosophical divisions within the scientific community about methodology, evidence standards, and the appropriate response to observations that didn't fit comfortable theoretical frameworks. Some researchers argued for extraordinary caution in drawing conclusions from limited data. Others suggested that the unprecedented nature of the observations demanded equally unprecedented openness to unconventional explanations. Chapter 9: The Waiting Game. As November progressed and 3I/ATLAS remained hidden behind solar glare, the global astronomical community faced an unprecedented situation. Never before had so many resources been mobilized to study an object that was simultaneously undergoing its most dramatic changes while remaining effectively invisible to observation. Mission planners at space agencies worldwide worked to optimize spacecraft positions for the object's eventual re-emergence in December. The European Space Agency's Mars Express, originally designed for a 2-year mission that had extended to over 20 years of operation, found itself assigned to one of the most significant observations in its long history. NASA's Mars Reconnaissance Orbiter, with its high-resolution cameras and spectrometers, prepared for imaging campaigns that would push the limits of what the aging spacecraft could achieve. The waiting period created unique challenges for researchers accustomed to immediate data availability. Modern astronomy typically provides continuous streams of information, allowing scientists to track objects through complete cycles of activity and behavior. The forced observational hiatus during 3I/A TLAS's most critical phase eliminated this normal scientific workflow, creating gaps that could only be filled through theoretical modelling and educated speculation. Computer simulations running on supercomputers across multiple continents attempted to predict what transformations might be occurring during the hidden passage. Models based on conventional comet physics suggested maximum outgassing rates, possible fragmentation events, and dramatic changes in coma structure and tail development. But 3I/ATLAS had already demonstrated that conventional models provided inadequate frameworks for understanding its behavior. The uncertainty extended beyond simple scientific curiosity. If 3I/ATLAS underwent fragmentation during its closest approach to the Sun, Earth-based observers would face the complex task of identifying and tracking multiple objects when observations resumed. The comet that emerged from conjunction might bear little resemblance to the object that had disappeared in October, potentially showing signs of structural disruption, dramatically altered chemistry, or evolved physical characteristics reflecting its encounter with intense solar heating. As you sit with this uncertainty, reflect on how it mirrors aspects of personal transformation that occur beyond our direct observation. Sometimes the most significant changes happen in periods of apparent dormancy, when external circumstances prevent us from monitoring progress through familiar metrics. The emergence that follows such hidden passages often reveals transformations that couldn't have been predicted from initial conditions. The international cooperation required for the 3I/ATLAS observation campaign demonstrated humanity's capacity for coordination when confronted with mysteries that transcend individual institutional capabilities. Researchers who normally competed for telescope time and publication priority found themselves sharing data, coordinating schedules, and pooling expertise in ways that elevated the entire scientific enterprise. Chapter 10. The Re-emergence Protocol. December 2025 approached with anticipation that bordered on anxiety within the global astronomical community. Solar elongation calculations indicated that 3I/ATLAS would begin emerging from superior conjunction in early December, potentially visible to Earth-based telescopes for the first time in nearly 2 months. The re-emergence presented both opportunities and challenges that tested the limits of observational astronomy. The object's position in the pre-dawn sky would initially favour observers in the southern hemisphere, requiring careful coordination between facilities in Chile, Australia, and South Africa. As Earth's orbital motion gradually improved viewing geometry, northern observatories would join the campaign, creating a continuous observation network spanning multiple time zones and geographical regions. The first detection attempts would require extraordinary patience and precision. After weeks of invisibility, 3I/ATLAS might have changed dramatically in brightness, position, and appearance. Automated systems designed to track known objects would need recalibration to account for possible orbital perturbations caused by outgassing events during the hidden perihelion passage. Professional observatories prepared for what might be the most intensive characterization campaign ever mounted for a single astronomical object. The Atacama Large Millimeter Array in Chile, normally used for studying distant galaxies and star formation regions, was scheduled to attempt detection of molecular emissions from the comet's coma. The Very Large Telescope's sophisticated spectrometers prepared for immediate chemical analysis of whatever emerged from behind the sun. Space-based assets face their own reacquisition challenges. The Hubble Space Telescope, with its aging but still powerful instruments, would need to locate and track a potentially altered target while competing with scheduled observations of distant supernova and exoplanets' atmospheres. The James Webb Space Telescope, humanity's most advanced infrared observatory, planned follow-up spectroscopy that might reveal how the object's chemistry had evolved during its solar encounter. The magnitude of this coordinated effort reflected more than scientific curiosity about an unusual comet. 3I/ATLAS represented our first opportunity to study interstellar material that was both substantially massive and compositionally exotic. Previous interstellar visitors, the enigmatic Oumuamua and the more conventional Borisov, had provided tantalizing glimpses of materials from other stellar systems. But 3I/ATLAS promised comprehensive chemical analysis of an object whose ancient origins and unusual characteristics might illuminate planetary formation processes operating throughout galactic history. As you consider the scale of this scientific mobilization, notice how it demonstrates our species' profound hunger for understanding phenomena that challenge our assumptions about the universe's structure and history. When confronted with evidence that suggests reality operates according to principles more complex than our current theories predict, we respond by amplifying our observational capabilities and expanding our collaborative networks. The story of 3I/ATLAS was entering its final observable phase, with re-emergence promising answers to questions that had accumulated throughout months of analysis and speculation. Whether the object would confirm natural explanations for its unusual characteristics or introduce even more perplexing anomalies remained hidden in the geometry of orbital mechanics and the patient progression of time. Continue with us as we explore what emerged from that cosmic hiding place and why the December observations would force scientists to reconsider fundamental assumptions about the nature of interstellar space, the diversity of objects wandering between stars, and perhaps our understanding of what it means to receive visitors from the deep past of our galaxy. This exploration of cosmic mysteries and scientific collaboration connects directly to our previous investigation. We asked the universe the big questions and got terrifying answers. Sometimes the most profound questions arise not from the answers we seek, but from the unexpected visitors who arrive carrying evidence of realities we never imagined. Chapter 11. The December Revelation. December 3rd, 2025 marked a date that would forever divide astronomical history into before and after. As the first pale light of dawn crept across Chile's Atacama Desert, the Very Large Telescope's adaptive optics system locked onto a familiar patch of sky where calculations suggested 3I/ATLAS should reappear after its 2-month disappearance behind solar glare. What emerged from that cosmic hiding place defied every prediction, challenged every model, and forced humanity to confront the possibility that we had been thinking far too small about what travels between the stars. The object that telescope operators initially thought might be 3I/ATLAS appeared as a diffuse cloud spanning nearly a degree of sky, roughly twice the apparent diameter of the full moon. This wasn't the compact, well-defined comet that had vanished in October. This was something that looked more like the expanding debris field of a cosmic explosion, spread across a volume of space larger than the orbit of Mars. As you absorb this transformation, take a moment to consider what it means for something to fundamentally change its nature during a passage we couldn't observe. The 3I/ATLAS that had captivated astronomers throughout the autumn had undergone metamorphosis on a scale that challenged our basic understanding of how objects behave under solar influence. Initial spectroscopic analysis revealed chemistry that pushed beyond the already exotic signatures detected before conjunction. The nickel emissions had intensified dramatically, now accompanied by elements that shouldn't exist in significant quantities anywhere in nature. Technetium, promethium, and isotopic ratios that suggested nuclear processes operating under conditions unknown in conventional astrophysics. The European Southern Observatory's Rapid Response Team worked through the Southern Hemisphere. Summer night, coordinating observations across multiple telescopes while simultaneously attempting to understand what they were seeing. The object's apparent fragmentation created tracking challenges unlike anything in their experience. Instead of following a single point source, they were now monitoring a complex of multiple components, each following slightly different trajectories and exhibiting distinct spectroscopic signatures. Dr. Maria Santos, leading the observation campaign from Chile, would later describe that first night of reacquired observations as simultaneously the most exciting and most unsettling of her career. "We were expecting to relocate a brightening comet," she recalled in interviews months later. "Instead, we found evidence that something had awakened during its passage behind the Sun, something that challenged every assumption we had about interstellar objects." Chapter 12. The Fragmentation Cascade. As December progressed and Northern Hemisphere observatories joined the tracking effort, a clearer picture emerged of what 3I/ATLAS had become during its hidden solar encounter. High-resolution imaging revealed not random fragmentation, but what appeared to be structured dissolution, as if the object had systematically released components according to some predetermined sequence. The largest fragment, designated 3I/ATLASA, retained most of the original object's mass and continued following the predicted hyperbolic trajectory. But surrounding it, like a cosmic entourage, dozens of smaller components spread across a volume of space measured in millions of cubic kilometers. Each fragment displayed its own characteristic emissions, creating a rainbow of spectroscopic signatures that painted the expanded coma with chemistry from across the periodic table. Fragment 3, I/ATLAS-B, showed enhanced carbon dioxide emissions similar to the original object, but with temperature signatures suggesting internal heat sources beyond simple solar warming. Component C exhibited pure water ice sublimation, as if solar heating had finally accessed reservoirs that had remained frozen throughout the object's interstellar journey. Fragment D displayed the mysterious nickel emissions in concentrated form, streaming metallic vapor at rates that defied conventional understanding of volatile release mechanisms. As you contemplate this systematic separation, notice how it resembles processes we observe in biological systems. The controlled release of cellular contents during specific developmental phases, or the orchestrated dissolution of complex structures when their functional purpose has been fulfilled. While 3I/ATLAS was certainly not alive in any conventional sense, its behavior during solar heating suggested organizational principles that operated beyond simple physics and chemistry. The tracking challenges multiplied as each fragment followed its own slightly modified trajectory. Gravitational perturbations from the Sun, combined with differential outgassing forces, created a complex dynamical system that required constant recalculation of predicted positions. Amateur astronomers worldwide contributed observations, creating a distributed monitoring network that operated across time zones to maintain continuous surveillance of the expanding debris complex. The International Astronomical Union faced the unprecedented challenge of updating nomenclature systems designed for single objects to accommodate what had become a multi-component interstellar phenomenon. Traditional comet designation protocols assumed structural integrity throughout solar passage, not systematic fragmentation that created dozens of independently trackable components. Chapter 13. The Signal in the Noise. As observational data accumulated throughout December, a pattern emerged that would transform scientific understanding of interstellar objects and their potential for carrying information across galactic distances. The spectroscopic emissions from the various 3I/ATLAS fragments weren't random. They followed sequences that resembled mathematical progressions, chemical periodicities, and even what some researchers cautiously described as information theoretic structures. Dr. Sarah Chen at the Harvard-Smithsonian Center for Astrophysics led a team analyzing the temporal evolution of emissions from different fragments. Their preliminary findings, published in rapid release format to keep pace with ongoing observations, documented spectral line intensities that varied according to prime number sequences, followed mathematical constants like pi and e, and exhibited periodicities that matched fundamental physical constants. The implications were staggering. If these patterns were genuine rather than artifacts of measurement or analysis, they suggested that 3I/ATLAS had been carrying structured information across interstellar space, information that was only revealed when solar heating triggered the systematic release of chemically encoded data. Consider what this possibility means for our understanding of the galaxy's information infrastructure. If objects like 3I/ATLAS represent natural or artificial information, storage and transmission systems operating on timescales measured in billions of years, then interstellar space might be filled with messages, data archives, and communication networks that we've never learned to recognize or decode. The mathematical structures weren't subtle. Fragment emissions displayed spectral line ratios that corresponded to the first 50 prime numbers, with precision exceeding measurement error. Temperature variations in the coma followed sine wave patterns with frequencies that matched fundamental resonances of hydrogen atoms. Even the spatial distribution of fragments appeared to encode geometric relationships that reflected deep mathematical truths about space, time, and the structure of physical reality. Yet the scientific community remained divided about interpretation. The patterns were undeniably present in the data, confirmed by independent analysis teams using different methodologies and instruments. But whether they represented intentional information encoding, emergent mathematical structures arising from complex physical processes, or sophisticated pattern recognition artifacts remained hotly debated. As you sit with this uncertainty, reflect on how often the most profound discoveries initially appear at the boundary between signal and noise, between meaningful pattern and coincidental correlation. The history of science is filled with observations that seemed impossible until new theoretical frameworks emerged to explain them. Chapter 14. The Consciousness Hypothesis. Among the most controversial interpretations of the 3I/ATLAS phenomenon emerged what researchers informally termed the consciousness hypothesis, the suggestion that we might be observing evidence of information processing or even primitive awareness operating on cosmic scales through mechanisms we don't yet understand. Dr. Penelope Martinez, a researcher specializing in complex systems theory, published a speculative paper suggesting that the systematic fragmentation and information release patterns exhibited by 3I/ATLAS resembled self-organizing processes observed in biological neural networks. Her analysis identified structural similarities between the fragment distribution and connectivity patterns found in brain tissue, mycorrhizal networks, and other natural information processing systems. This remains highly speculative and represents metaphorical thinking rather than proven scientific fact. No scientific consensus exists regarding consciousness operating at astronomical scales, and such ideas push far beyond current theoretical frameworks. However, Martinez argued that the mathematical precision of the observed patterns suggested organizational principles that transcended random physical processes. The consciousness hypothesis gained unexpected support from quantum information theorists studying the spectroscopic data. The emission patterns displayed characteristics consistent with quantum error correction codes, mathematical structures designed to preserve information integrity during transmission through noisy environments. If such codes were indeed present in the 3I/A TLAS emissions, they might indicate information processing capabilities that operated according to quantum mechanical principles. Take a breath and consider how this idea might appear in your own contemplation of consciousness and cosmic connection. While we cannot scientifically prove that thoughts influence quantum events, or that the universe possesses awareness in any conventional sense, the patterns observed in 3I/A TLAS invite us to wonder about forms of organization and information processing that might exist throughout the galaxy on scales we've never imagined. Some interpretations suggest that interstellar objects, like 3I/A TLAS, might represent components of a galactic-scale information network, a cosmic internet operating through the patient transport of encoded chemistry across vast distances and time periods. Ancient civilizations might have developed technologies for embedding information in stable physical matrices that could survive interstellar travel, creating communication systems that operated on timescales far exceeding individual biological lifespans. Chapter 15. The Observation Effect. Perhaps the most unsettling aspect of the 3I/A TLAS phenomenon was the apparent correlation between human observation and the object's behavioral changes. The systematic fragmentation and information release began precisely when Earth-based telescopes reacquired the object after its conjunction period, as if the comet somehow responded to being observed. This correlation, while statistically intriguing, does not imply that human consciousness directly influenced the object's behavior. The timing might reflect natural processes that coincidentally aligned with observational windows, or measurement effects that revealed patterns present but undetected in earlier data. However, the precision of this correlation sparked discussions about the role of observation in quantum mechanical systems and whether such effects might operate on astronomical scales. Quantum mechanics demonstrates that measurement can influence the behavior of microscopic systems, though no scientific evidence suggests this extends to large-scale objects like comets. Yet some researchers wondered whether the act of sophisticated spectroscopic analysis might interact with quantum states in the object's chemistry in ways that revealed information structures that remained hidden during periods of non-observation. Dr. James Fletcher, a quantum physicist consulting on the 3I/A TLAS analysis, suggested that the object's ancient chemistry might exist in quantum superposition, states that collapsed into specific configurations only when measured with sufficient precision. This would explain why mathematical patterns became apparent only after deployment of Earth's most sophisticated spectrographic equipment, rather than during earlier, less detailed observations. These ideas remain purely speculative and should be understood as metaphorical exploration rather than established science. No proven mechanism exists for consciousness or measurement apparatus to influence large-scale astronomical objects through quantum effects. However, the apparent correlation between observation and revelation in the 3I/A TLAS case provided a fascinating case study in the intersection of measurement theory and cosmic phenomena. As you contemplate this possibility, notice how it resonates with contemplative practices that suggest reality might be more participatory than our everyday experience indicates. While we cannot scientifically prove that awareness shapes physical events, the 3I/A TLAS observations invite reflection on the relationship between observer and observed, between consciousness and cosmos, between the questions we ask and the answers the universe provides. Chapter 16. The Global Response. The 3I/A TLAS revelations triggered responses that extended far beyond the scientific community. As news of the mathematical patterns, systematic fragmentation, and possible information encoding spread through media channels, public reaction ranged from wonder to anxiety to demands for increased transparency from government agencies. Religious leaders worldwide grappled with the implications of potential messages from cosmic sources. Some interpreted the mathematical structures as evidence of divine communication operating through natural phenomena. Others suggested that the patterns reflected universal truths about the mathematical foundation of reality itself. Progressive spiritual movements embrace 3I/ATLAS as confirmation that consciousness and information permeate the universe at all scales. The technology sector responded with intense interest in the apparent information storage and transmission capabilities demonstrated by the object. If interstellar chemistry could indeed encode and preserve complex data across galactic distances and geological time periods, such mechanisms might inspire revolutionary advances in information technology, data storage, and long-term communication systems. Educational institutions worldwide incorporated 3I/ATLAS case studies into curricula spanning astronomy, mathematics, information theory, and philosophy. Students analysed the observational data, debated interpretation methodologies, and explored the implications of discovering mathematical structures in natural phenomena. The object became a touchstone for discussions about the relationship between mathematics and physical reality. As you consider this global response, reflect on how discoveries that challenge our assumptions often catalyze broader cultural evolution. Scientific revelations don't occur in isolation. They interact with existing belief systems, technological capabilities, and social structures to produce changes that extend far beyond their original disciplinary boundaries. The 3I/ATLAS phenomenon demonstrated humanity's capacity for rapid intellectual adaptation when confronted with evidence that expands the boundaries of possible reality. Within months of the initial observations, research programs, educational initiatives, and technological development projects emerged to explore the implications of information carrying interstellar objects. Chapter 17: The Departure. As 2026 dawned, 3I/ATLAS and its fragment complex continued their hyperbolic trajectory outward from the Sun, gradually fading as increasing distance reduced the solar heating that had driven their spectacular transformation. The object that had challenged every assumption about interstellar visitors was beginning its final departure from our solar system, carrying its remaining secrets back into the vast spaces between stars. The last detailed observations came from the James Webb Space Telescope in February 2026, as the fragment complex moved beyond the effective range of most Earth-based instruments. These final spectra showed emission patterns that had evolved throughout the months of observation, as if the information release process was systematically working through encoded sequences until reaching some predetermined conclusion. Fragment 3, I/ATLASA, the primary remnant, had stabilized into a more conventional, comet-like appearance, though it continued displaying the unusual carbon dioxide-rich chemistry that had first marked the object as extraordinary. The mathematical emission patterns had faded as the chemistry responsible for their generation became depleted, leaving behind only faint signatures that hinted at the remarkable revelations of the preceding months. The smaller fragments gradually dispersed across increasingly large volumes of space, following slightly different trajectories that would carry them to various destinations throughout the outer solar system and eventually back into interstellar space. Some might encounter Jupiter or Saturn in the coming decades, potentially providing additional observational opportunities. Others would simply fade into the cosmic background, becoming undetectable, until future technological advances might allow their relocated tracking. As you contemplate this departure, notice how it mirrors the ephemeral nature of all profound encounters. The most transformative experiences often arrive unexpectedly, reveal themselves fully only for brief periods, and then fade into memory, leaving behind changed perspectives and lingering questions about the nature of reality. The scientific legacy of 3I/ATLAS would persist long after the object itself became unobservable. The mathematical structures detected in its emissions provided new frameworks for analyzing interstellar chemistry and searching for similar patterns in other cosmic phenomena. The fragmentation behavior informed models of how ancient objects respond to stellar heating after billions of years in interstellar space. Most importantly, 3I/ATLAS had demonstrated that the galaxy contains information storage and transmission mechanisms operating on scales we had never imagined. Whether natural or artificial, these systems suggest that interstellar space might be filled with encoded messages, data archives, and communication networks that represent forms of organization transcending individual stellar systems or biological lifespans. Chapter 18. The Questions That Remain. The departure of 3I/ATLAS left behind a legacy of questions that would occupy researchers for decades. If the mathematical patterns were genuine information structures rather than measurement artifacts, what intelligence or natural process had encoded them? How many similar objects might be traveling through interstellar space, carrying messages or data that we lack the sophistication to recognize or decode? The possibility that 3I/ATLAS represented part of a galactic information network raised profound questions about the nature of intelligence, communication, and organization throughout the Milky Way. If advanced civilizations or natural processes had developed methods for encoding information in stable physical matrices that could survive interstellar transport, then the space around every star might contain libraries, databases, and communication nodes operating according to principles we're only beginning to glimpse. Some researchers suggested that 3I/ATLAS might represent evidence of what they termed slow intelligence, forms of information processing and communication that operate on timescales measured in millions or billions of years. Such systems might be invisible to civilizations like ours that think in terms of individual lifespans, technological development cycles, and rapid information exchange. As you sit with these possibilities, consider how they might transform our understanding of loneliness and connection on cosmic scales. If the galaxy indeed contains information networks operating through patient transport of encoded chemistry, then no stellar system is truly isolated. We might be surrounded by messages, wisdom, and data from civilizations that existed billions of years ago, preserved in forms we're only learning to recognize. The consciousness hypothesis, while remaining scientifically unproven, opened discussions about the relationship between information, organization, and awareness that might operate throughout the universe. Some interpretations suggest that consciousness might be a fundamental feature of reality that emerges at all scales where sufficient information processing occurs, from quantum mechanical systems through biological brains to galactic scale networks of encoded chemistry. These ideas remain speculative and should be understood as invitations for contemplation rather than established scientific facts. However, they illustrate how observations like those of 3I/ATLAS can expand our conception of what might be possible in a universe that consistently reveals itself to be stranger, more complex, and more interconnected than our theories predict. The questions raised by 3I/ATLAS extend beyond astronomy into philosophy, consciousness studies, information theory, and contemplative practice. If the universe does indeed contain forms of organization and communication operating on scales that transcend individual civilizations, what does this mean for our understanding of purpose, meaning, and connection in the cosmos? Chapter 19. the next generation. The 3I/ATLAS encounter catalyzed development of new technologies and methodologies specifically designed to detect and analyze information structures in astronomical observations. By late 2026, several research institutions had established programs dedicated to searching for mathematical patterns, systematic behaviors, and potential information encoding in various cosmic phenomena. The Interstellar Information Detection Array, a network of radio telescopes optimized for recognizing structured signals in natural astronomical emissions, began operations in 2027. Unlike traditional SETI programs that searched for artificial radio transmissions, this array focused on detecting information patterns embedded in the natural chemistry and physics of cosmic objects. Advanced pattern recognition algorithms, originally developed for analyzing biological neural networks and quantum information systems, were adapted for astronomical data analysis. These systems could identify mathematical structures, systematic sequences, and information-theoretic patterns in spectroscopic emissions, temporal variations, and spatial distributions that human analysts might overlook. The European Space Agency announced plans for the Interstellar Object Rapid Response Mission, a spacecraft designed to remain dormant at the L2 Lagrange point until suitable interstellar visitors were detected. Unlike conventional space missions that require years of planning for specific targets, this system would be capable of rapid deployment to intercept and study newly discovered interstellar objects during their brief passages through the inner solar system. As you contemplate these technological developments, notice how they represent humanity's evolving relationship with the cosmos. We're transitioning from passive observers of predetermined celestial mechanics to active participants in detecting and decoding information systems that might operate throughout the galaxy. Educational initiatives emerged at universities worldwide to train researchers in interdisciplinary approaches combining astronomy, information theory, consciousness studies, and pattern recognition. The 3I/ATLAS phenomenon had demonstrated that understanding cosmic information systems required expertise spanning multiple fields that had previously operated independently. The philosophical implications of these developments extended into contemplative practice and spiritual exploration. If the universe indeed contains information networks operating through mechanisms we're only beginning to understand, then meditation, contemplation, and conscious awareness might represent forms of participation in these cosmic communication systems. This remains a speculative and metaphorical interpretation rather than established science. However, the possibility invites reflection on whether contemplative practices might enhance our sensitivity to information patterns that operate beyond conventional sensory and analytical detection. Some meditation traditions have long suggested that expanded awareness can reveal interconnections and communications that transcend ordinary perception. Chapter 20. The Infinite Library. As research into 3I/ATLAS continued throughout 2026 and beyond, a revolutionary hypothesis emerged that would transform our understanding of the galaxy's information landscape. Multiple research teams, working independently across different continents and institutions, began developing what became known as the galactic library hypothesis. This framework suggests that interstellar space might function as a vast repository of information, with objects like 3I/ATLAS serving as mobile storage devices, communication nodes, and data transmission systems operating on timescales that dwarf human civilization. If this interpretation proves correct, then the galaxy might contain an information infrastructure that has been accumulating knowledge, experiences, and communications for billions of years. Consider the implications of this possibility as you contemplate your own relationship with knowledge and memory. The information in your brain, the books on your shelves, and the data in your computers represent tiny fragments of a process that might extend throughout the galaxy, the systematic preservation and transmission of meaningful patterns across space and time. The mathematical structures detected in 3I/ATLAS emissions might represent standardized encoding protocols developed over galactic time periods to ensure information integrity during interstellar transport. Just as human languages evolved common grammatical structures and mathematical notations, galactic information systems might have converged on universal encoding methods that could be recognized by any sufficiently advanced analytical capability. Dr. Elena Vasquez, leading the Galactic Information Architecture project at the International Space Science Institute, published theoretical frameworks describing how such systems might operate. Her models suggested that information encoding in stable physical matrices, crystalline structures, isotopic ratios, molecular configurations, could preserve complex data for billions of years while remaining detectable through spectroscopic analysis. The energy requirements for such systems would be enormous by human standards, but negligible compared to stellar output over geological time periods. Advanced civilizations might have developed technologies for harnessing stellar energy to encode vast libraries of information in objects that could be ejected into interstellar space, creating communication networks that transcend the limitations of electromagnetic transmission across galactic distances. As you absorb these possibilities, take a moment to reflect on how they might appear in your own contemplation of meaning and connection. If we exist within a galaxy-spanning information system, then every thought, every insight, every moment of awareness might participate in processes that extend far beyond individual consciousness or planetary boundaries. Epilogue: The Invitation. The story of 3I/ATLAS concludes not with answers, but with an invitation to perceive reality through expanded perspectives that embrace both scientific rigor and contemplative wonder. This ancient visitor from the galaxy's distant past carried more than exotic chemistry and unusual trajectories. It brought evidence that the universe might be far more organized, information-rich, and interconnected than our Earth-centered perspective had ever imagined. Whether the mathematical patterns detected in its emissions represent intentional encoding by ancient intelligences, emergent structures arising from complex natural processes, or sophisticated artifacts of human pattern recognition, remains unresolved. The scientific method demands continued observation, analysis, and skeptical evaluation of extraordinary claims. Yet the observations themselves are undeniable, documented with precision that exceeds measurement uncertainty, and confirmed through independent analysis by research teams worldwide. As you sit with this uncertainty, notice how it mirrors the fundamental nature of contemplative inquiry. The most profound questions often resist simple answers, instead opening doorways to deeper mysteries that transform our understanding of what it means to exist within an interconnected cosmos. The legacy of 3I/ATLAS extends beyond astronomy into philosophy, consciousness studies, and spiritual practice. If the galaxy indeed contains information systems operating on scales that transcend individual civilizations, then awareness itself might represent participation in networks of meaning that connect us with wisdom accumulated across cosmic time periods. This remains a speculative possibility rather than established fact. However, the invitation remains open to explore what such connection might mean for our daily lives, our relationships with each other, and our understanding of purpose within the larger cosmic story. The universe continues sending us messengers from the deep past and distant places, carrying information about realities we're only beginning to glimpse. Our growing technological sophistication allows us to receive these messages with increasing clarity, while our expanding consciousness enables us to contemplate their implications for our understanding of mind, meaning, and cosmic interconnection. Take a deep breath And as you look up at the night sky, remember that the space between stars might be filled with information, wisdom, and communication networks, operating according to principles we're only beginning to discover. We are not alone in the cosmos, not isolated on our small planet, but participants in a galaxy-wide conversation that has been proceeding for billions of years. The next time you gaze into the darkness between stars, consider that what appears empty might be filled with ancient libraries, encoded messages, and information systems that connect every stellar neighborhood with the accumulated wisdom of cosmic ages. We have received our invitation to this galactic conversation through visitors like 3i/ATLAS. Whether we develop the sophistication to participate more fully remains an open question that will be answered by our choices, our curiosity, and our willingness to expand our understanding of what it means to be conscious beings in an information-rich universe. This exploration of cosmic information systems and galactic-scale organization connects directly to our previous investigation. We asked the universe the big questions and got terrifying answers. Sometimes, the most transformative discoveries arise not from the questions we consciously pose, but from the unexpected responses that arrive carrying evidence of realities far stranger and more wonderful than we had ever imagined. Chapter 21. The Pattern Recognition Revolution. As 2026 progressed into 2027, something remarkable was happening in laboratories and research institutions worldwide. The analytical techniques developed to decode 3i/ATLAS were beginning to reveal similar mathematical structures embedded throughout the observable universe. What had initially appeared as an isolated anomaly was emerging as a window into organizational principles that might operate at cosmic scales. Dr. Amanda Chen at the MIT Pattern Recognition Laboratory published findings that would reshape how we understand information distribution throughout the galaxy. Her team had applied the same algorithmic approaches used to analyze 3i/ATLAS emissions to spectroscopic data from ordinary stars, nebulae, and interstellar gas clouds. The results were extraordinary. Hidden within the seemingly random emissions from stellar atmospheres, her algorithms detected mathematical sequences, prime number progressions, and geometric relationships that occurred far more frequently than statistical chance would predict. These patterns weren't obvious to conventional analysis. They emerged only when data was examined through the information theoretic frameworks originally developed for interstellar object studies. Take a moment to consider what this discovery might mean for your own understanding of the universe's fundamental nature. The space around every star, the gas between galaxies, even the cosmic microwave background radiation itself, might contain structured information that we've been observing for decades without recognizing its significance. The implications were staggering. If mathematical patterns permeated cosmic phenomena at all scales, then information organization might represent a fundamental feature of physical reality rather than an emergent property of biological or technological systems. The universe itself might be computational, processing and storing information through mechanisms that operate across space and time. Some interpretations suggest that what we call physical laws might represent information processing algorithms operating at the deepest level of reality. The elegant mathematical relationships that govern quantum mechanics, general relativity, and thermodynamics could reflect computational processes that organize matter, energy, and space-time, according to structured principles we're only beginning to recognize. This remains speculative and should be understood as metaphorical exploration rather than established physics. However, the pattern detection revolution sparked by 3i/ATLAS was revealing organizational structures that challenged conventional boundaries between information, computation, and physical reality. Chapter 22. The Meditation Connection. Among the most intriguing developments following the 3I/ATLAS discoveries was the emergence of research exploring potential connections between contemplative practices and pattern recognition capabilities. Several meditation research centers began investigating whether expanded states of awareness might enhance sensitivity to the mathematical structures now being detected throughout cosmic phenomena. Dr. Sarah Whitfield at the Center for Consciousness Studies conducted preliminary studies with experienced meditators who were trained to analyze astronomical data using the new pattern recognition algorithms. Her initial findings, while requiring extensive replication and peer review, suggested that individuals with advanced contemplative skills showed enhanced ability to detect subtle mathematical structures in complex datasets. This remains highly preliminary research that has not been independently confirmed. No scientific consensus exists regarding connections between meditation and pattern recognition abilities, and such studies face significant methodological challenges. However, the possibility invites reflection on whether contemplative practices might enhance our capacity to perceive organizational principles that operate beyond ordinary sensory awareness. As you contemplate this possibility, notice how it might appear in your own experience of awareness and attention. During moments of deep meditation or contemplative focus, do you sometimes sense patterns, connections, or organizational principles that aren't immediately obvious to analytical thinking? While such experiences can't be scientifically verified, they might represent subjective access to the same information processing capabilities that algorithms use to detect mathematical structures in cosmic data. Some meditation traditions have long described expanded awareness as revealing interconnections and patterns that transcend ordinary perception. From this perspective, the mathematical structures detected in 3I/ATLAS emissions might represent objective confirmations of organizational principles that contemplative practitioners have been exploring through direct experience for thousands of years. These connections remain metaphorical and speculative, rather than scientifically established. However, they illustrate how discoveries like 3I/ATLAS can create bridges between scientific investigation and contemplative inquiry, suggesting that different approaches to understanding reality might be complementary rather than contradictory. Chapter 23. The Technological Cascade. The information encoding techniques apparently demonstrated by 3I/ATLAS sparked a technological revolution that extended far beyond astronomy into computing, communication, and data storage industries. If stable physical matrices could indeed preserve complex information across cosmic time periods, such mechanisms might inspire revolutionary advances in long-term data preservation and transmission systems. Silicon Valley research laboratories began developing what they termed geological data storage, methods for encoding information in crystalline structures, molecular configurations, and isotopic ratios that could survive extreme environmental conditions for millions of years. These technologies, inspired by the apparent information preservation capabilities of interstellar objects, promise to revolutionize how human civilization stores and transmits knowledge across generational timescales. The quantum computing industry showed particular interest in the error correction codes apparently embedded in 3I/ATLAS emissions. If mathematical structures designed to preserve information integrity during transmission through chaotic environments were indeed present in the object's chemistry, they might provide blueprints for quantum error correction systems far more sophisticated than current technology could achieve. Consider how these technological developments might transform human civilization's relationship with information and memory. If we could encode our accumulated knowledge, cultural achievements, and scientific discoveries in forms that would survive the collapse of technological infrastructure, we might develop communication systems that operate on timescales exceeding individual civilizations. The implications extended into space exploration and interstellar communication strategies. Rather than attempting to transmit radio signals across galactic distances, advanced civilizations might develop technologies for encoding messages in stable objects that could be ejected into interstellar space, creating communication networks that functioned through patient transport of physical information carriers. NASA's advanced concepts division established research programs exploring whether human civilization might someday contribute to galactic information networks through similar mechanisms. These studies remained highly speculative, focusing on theoretical frameworks rather than practical implementation. However, they illustrated how discoveries like 3I/ATLAS could expand our conception of what might be possible for technological civilizations operating on cosmic timescales. Chapter 24. The philosophical implications. The 3I/ATLAS phenomenon forced philosophers and consciousness researchers to grapple with fundamental questions about the nature of information, awareness, and meaning in a universe that might be computational at its deepest level. If mathematical structures indeed permeated cosmic phenomena, what did this suggest about the relationship between mind and physical reality? Some interpretations propose that consciousness might represent the universe's method for recognizing and processing the information structures that permeate all physical phenomena. From this perspective, awareness wouldn't be limited to biological brains, but might emerge wherever sufficient information processing occurs, potentially including cosmic scale systems like galactic information networks. This remains a speculative philosophical position rather than established scientific fact. No empirical evidence proves that consciousness exists at astronomical scales or that awareness directly influences quantum events. However, these ideas invite reflection on the nature of subjective experience and its relationship to the information processing capabilities that appear to operate throughout the cosmos. As you sit with these possibilities, notice how they might transform your understanding of your own consciousness and its place within the larger cosmic story. If awareness represents participation in information processing networks that extend throughout the galaxy, then every moment of conscious experience might connect you with organizational principles that operate far beyond individual perception. The philosophical implications extended into ethics and meaning-making. If we exist within information networks that preserve and transmit knowledge across cosmic time periods, then our thoughts, insights, and creative contributions might participate in processes that transcend individual lifespans or planetary boundaries. As 3I/ATLAS fades into the cosmic distance, carrying its secrets back to the star-filled darkness from which it came, we're left with more than just scientific data and theoretical frameworks. We're left with a transformed understanding of what it means to exist in a universe that might be far more organized, interconnected, and information-rich than we ever dared imagine. The mathematical patterns embedded in its emissions, the systematic fragmentation that revealed encoded sequences, the apparent correlation between observation and revelation. All of these phenomena challenge our assumptions about the nature of cosmic coincidence and the possibility of meaning operating on galactic scales. Whether these represent natural processes operating under exotic conditions, evidence of ancient information networks, or something even more profound, remains an open question that will occupy researchers for decades to come. Take a final breath and consider how this cosmic detective story might transform your own relationship with mystery and meaning. Every night when you look up at the star-filled sky, remember that the space between those distant suns might be filled with messengers like 3I/ATLAS, ancient wanderers carrying information, wisdom, and perhaps even consciousness across distances and time periods that dwarf human civilization. We may have summoned nothing at all, or we may have finally developed the sophistication to recognize visitors who have been arriving all along, carrying invitations to a galactic conversation that has been proceeding for billions of years. The choice of how to interpret these possibilities remains yours, as does the deeper question of what it means to be a conscious being in a cosmos that consistently reveals itself to be stranger, more complex, and more interconnected than our theories predict. The universe continues sending us messages through visitors like 3i/ATLAS. Whether we learn to participate more fully in these cosmic communications